So today we're going to talk about reviewing concepts of probability and all the things that we've learned so far with the concepts. If we were looking at these formulas, this is the probability for independent events. And these formulas here are for dependent events. And we also need to have in our bank the idea of odds in favor, which is the probability of an event happening to a probability of event not happening. And odds against is the probability of the event not happening to the probability of the event happening. So all these tools that we have, plus if we have to look at standard deck of cards, we've got these properties of sums of two dice. We've got these properties, and we can always look back to these ideas as we move forward. And at any time as you're watching this, feel free to hit pause to try some of the examples, and then hit play to check your work and see if it matches up with the thinking that we've seen. All right. So the basic questions of odds and probability, I think they're pretty straightforward. And one of the big things we want to be able to do is define our event. So we're looking at the probability of rolling some less than the sum of 8. So we have to define that event. And we also need to find out how many articles do we have total. So we know, using this table on the front side, we know that there's 36 total outcomes. And we can look back, and when we're looking at sums of 8, less than sums of 8, we know that we can add up how many are here. So I've got 6 plus 5 plus 4 plus 3 plus 2 plus 1. 1, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we know the probability of this event is 21 out of 36. And we know that if we're going to leave these as a fraction, we have to reduce our fraction. So that's going to be 7 out of 12. Okay. And I can use my calculator to get a probability and just by 7 divided by 12. So I can say that that is, as a decimal place, 0.583. Or I can write it as a percentage. And we're always going to think of 3 decimal places there, 1 decimal place for a percent. So I don't think that's going to be too big of a deal for just the idea of basic probability. Now we're looking at odds in favor. So if I look at what my event is, we can pick any letter other than S or P. B sounds great. I'm looking at picking an ace. All right. And the other thing is I need to know how many cards I'm dealing with. All right, which is 52. So a probability of picking an ace, which is 4 out of 52. And it's always good to try to reduce that. All right. If I divide that by 4, I get that. But the question is asking me, what's the odds in favor? Well, the odds in favor is the probability of the event to the probability of the event not happening. So we need to go back here. Let's make that a B. All right. We have to find the complement. Well, we know the complement has to be 12 out of 13. Okay. And then I can put that in. And we know that these have to be whole numbers. So if I'm looking at, there's 1 part doing it, 12 parts not doing it, and I can get that answer. Sometimes we have to go backwards. All right, the odds against Vegas winning the Stanley Cup this year is 13-2. What's the probability of them winning it? Well, we have to look at our event. Vegas winning is our event. all right? The other thing is we know the odds against. Well, that's the probability of the event not happening to the probability of the event happening. And we know that that's 13 to 2. Well, just like the question above, we have 1 doing it and 12 not doing it. How did we get 13? Well, if we add those two up, that gives the total. So this is actually equal to 13 out of 15, 2 out of 15, even though it's not quite a ratio, but this helps us to connect that. So the question is, what's the answer? Well, I have to go back to my question and say, what's the probability of Vegas winning the Stanley Cup? That's got to be C. So the probability of C happening, well, if I look at my notation, well, it's got to be 2 out of 15 because that's the label for odds against. So it's important to have this communication down so you know exactly what you're looking at. All right. 4. Now we're looking at our counting principles. So we're looking at 9 runners in a race, all right, and they're randomly sorted. All right, 3 fastest side by side. Well, we know by looking at this, we're looking at factorials as our counting principle. So our N of S is looking at 9 runners. So my 9 factorial I'm looking at. And the event A is I'm looking for the 3 fastest side by side. All right? So if I'm looking at this, some people may have to actually write out 1, 2, 3, 4, 5, 6, 7, 8, 9. Put the 3 fastest side by side. Put the other ones in there. So I've used 3 out of the 9. So 6, 5, 4, 3, 2, 1. And since this group can move anywhere, so that is 7 factorial times 3 factorial. So now I can say the probability of A is 7 factorial times 3 factorial divided by 9 factorial. All right, and we can type that in our calculator just the way it is. So I can do, if I'm looking at 7 factorial times 3 factorial, right? Divided by 9 factorial. All right, I get a little funky answer there, so that I know that that answer is 0.083. The other thing you can take a look at is you could reduce this, so 7 factorial times 3 factorial, and I can write that out to get to 7 factorial. Cancel that out. 3 factorial 6 over 9 times 8 is 72. And if I divide that by 6, I get 1 over 12, which is the same as 0.083. Okay? I'm not saying you have to do that pathway, but if you want to show some high order thinking, that's one way I can do that. Okay? If you think you know what to do for question B, good idea to push pause and see if you can do part B on your own and then hit play and then we can talk about it. So one thing I did was I looked at what the event I'm looking at. So I'm looking for the 2 slowest not side by side, but I know that it's easier to find the 2 slowest side by side and then I can find the complement afterwards. So with my thinking here, I know that the 2 slowest side by side is 8 factorial times 2 factorial, and I could have did this 7, 6, 5, 4, 3, 2, 1, and I could have expanded it out like that. And if I reduce it out, I get 2 over 9. And you want to leave that as a fraction because we're finding the odds in favor. So this is where maybe you do a little bit of reduction. all right? And then I want to find the complement, and then I have to think about what's the odds in favor of the event. Well, I have to put in the probability of doing it to the probability of not doing it to get my answer to 7. So hopefully it gives you an idea of how to do that and take it from a fraction to a ratio. You got to leave those as fractions. All right. If I look at this one here, if you randomly choose, I'm making groups. So this tells me I'm using combinations. And I want to be able to understand what I'm finding. Well, my N of S, I have to look at, well, how many people do I have? Well, I have 8 males. I have 7 females, which means I have a total of 15. And I need a group of 5. So sometimes writing in that communication makes it easy to do the work. So I know my bottom part of my fraction is going to be 15C5. Then we have to look at, well, what are we finding? Well, we're finding the probability at least 3 females. All right? So my event A is at least 3 females. But to figure that out, I could do a little chart. I can pick 3 females. I can pick 4 females, or I could pick 5 females. And I can't go any higher because my group of 5, I would have too many if I had 6. All right? And then I look at, if I have 7 females and I choose 3, 7 choose 3. And I know my total has to be that. I should be able to look through and then how many males do I need to choose? Hopefully, you would say that I have to choose 2. Because I need a total of 5. I need 3 females, 2 males. Get that? And I can go to my calculator. All right, and I can go to my calculator. I can find the NCR button on my calculator. NCR, let's actually start with a fraction. I can do NCR of 7 and 3, 7 comma 3, close the bracket, times, go back to my function, 8C2, try it again, comma 2, close the bracket, and then I'm going to divide by 15, comma 5. All right, so I can think of it like that. So I can take that answer, 0.326. All right, that's what I got. That's what it looks like. All right, I'm going to hit pause. I want you to try 4 and 5 and see if you get the same answers as I do. Hit pause now. So hopefully when you were doing your work, you got 7C4, 8C5, then divide by the same because your NS does not change. And then I can do the same there. And we know to add those results because the idea of OR comes into play here. That tells us to add. All right. And then a little therefore sentence helps to clear up the answer. All right. Independent and dependent events. The hardest part with these is understanding which type it is so that you can go back to the front of the booklet to say, hey, I'm using independent probability and dependent probability. And the biggest thing that we want to look for is the word given. Is that word given used in our sentence? If it's no, it's independent. If it's yes, it's dependent. So let's take a look at this. Probability of rain tomorrow is 35%. Probability of Mr. Brzee playing a great game of golf given that it rains, ding, 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 is 20%. Probability of Mr. Z having rain given that it doesn't rain, ding, 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 is 45%. What's the probability of rain occurring and Mr. Z not playing a good game? So this is a dependent event. So that means we need to use our given scenarios. First of all, we want to define our events. A is rain. A prime is no rain, because there is a possibility of that happening. B is great game. And B prime is not a great game. And that all four of those scenarios are possible. And if I look back at our question here, probability of rain, there's my A, is 35%. Probability of A prime is the complement. Probability of Mr. Z playing a great game, B, given that it rains. So great game given it rains is 20%. And probability of a great game given it doesn't rain. There's the complement. And this is where the hardest part comes in. I have to find the complements. So I know the complement of that is that. The complement of that is that. Okay, that's not too bad. And you're always complementing the B. All right, and you leave the A the same symbols. So if I draw a line there, these are complements, these are complements. So the question now is, what are we finding? The probability it rains, that's A, occurring, and me not having a great game. That's B prime. And since we know that this is a dependent event, we can go back and say, well, which version we're using? Not this one. I want to pick this one because we have the given part. B prime given A times the probability of A. So now I just look for where's that notation. There it is, 0.80 times 0.20. And then I can just get my answer. 0.8 times so there you go, 16% of the time it rains and not having a great game. All right, and I can still make that a percentage. I can make that a decimal. Doesn't matter. All right. Here's the second one. And what I'm going to do is I'm going to hit pause here, and I want you to tell me, is this going to be independent or dependent? And tell me why. So if you've seen that, the idea it is independent because there's no word given, right? B does not give an A. But what we're still looking at are two events. All right, Mr. Z having a honey-to-do list. So I have a list or no list. And having mark assignments. So if I have marking or no marking. Those are the two things. And from there, I should be able to find those. All right, since these are independent event, I don't have any givens here. So what I want you to do is hit pause and tell me what the four individuals' probabilities are. So hopefully you've had a chance to write down them. And if I was looking at this, there's my list. That's my A. There's my probability of A. Here's my B. There's the probability of B. And then I can find the probabilities. So 85%, the complement of that is that notation. 64%, and the complement of that is that. So the question is, What's the question? What's the probability of no list? So that's A prime, and no assignments, B prime. So that's what I'm solving for. And since this is independent, I can go back to my independent probability. I can write that there. So the probability of A prime times the probability of B prime. So 15% times 36, and I can get my answer. 0.15 times 0.36. Right, and you can write it as a percentage, you can write it as a decimal, that is totally fine. All right. So if I'm looking at this question, the following table shows people who were surveyed, but their feelings about who's the better math teacher. All right. So what I want you to do is hit pause here, and I want you to tell me, is this going to be dependent or independent? And why? Hit pause, tell me what you think. Hopefully you said given. And if you look at it, I'm like, oh, I didn't read the question, da-da-da. What's the probability of a person selecting Brazil if they were female? Well, I think I should have had the word given in there. Given, there's the word given. All right, so these are independent probabilities. So we know that we're going to have 4 events. All right. All right. Actually, you know what? If it's this, we have to take our events from there. So B given A, which it says right there, given that they're female, B has to be Brazil, and A has to be female. Or I guess in this case, let's make it grade 9. This will be correct on your sheet. All right. So I go back to my formula, A, B, probability of A, and then I look. Well, how many pick female and grade 9s in Brazil? Well, that's 46. Out of, oh crap, I got to figure out this. So I got to add up these scenarios. So I got to do 46 plus 24, which is 70, 19 plus 36 is 55. So that adds up to 125. So there should be 125 total. But if we go down the other way, 46 plus 19 is 65, and if I add that up as 60, I get 125. All right, so the question is, what goes on the bottom? Is it going to be 65 or 70? Well, it depends on what that is. A is grade 9s, so I need the total grade 9s. So 70 over 125. So that's 46 out of 70, right? Because they're dividing by fractions, those fractions get canceled out. All right, and then I can just divide that out. If I wanted to leave it as a fraction, you could. All right, but that reduces to that. Or you can make it a decimal, 0.657. All right, so there's part A. Part B, odds affecting a grade 12 student. If Northwood, so B is grade 12. A is Northwood. All right, I can do that. Okay. So what I'm gonna do is I'm gonna hit pause. I want you to see if you can get down to answering the questions as odds in favor and see if you can make that connection. So hopefully when you were doing this, you're able to go back to your chart and say, well, how many grade 12s liked working with Mrs. Northwood? There was 36 out of the 125. And then I have to go back and say to myself, how many liked you and Mrs. Northwood? Well, it's got to be 60. So I actually screwed up because I was doing it really fast. So this actually should be 60. That should be 60. All right. Maybe I try to reduce that. Maybe I try to reduce that. And then I can go to my odds in favor. So odds in favor of that would be 9 out of 15, and then 6 out of 15. And actually that could be reducing further. So that would be 3 out of 5. So 3 out of 5 that like it, 2 out of 5 that didn't like it. So the odds in favor is 3-2. All right. So it's all about reducing fractions. All right. Sometimes it works, sometimes it doesn't. But you got to think about, did I answer the question? All right. Last question. If I was reading this question, I want you to hit pause here for a minute. I want you to read this question and tell me what type of question would this be? Hopefully you said it's going to be a Venn diagram question because there's lots of overlap. People like science and English. Some people only like science. Some people only like math, right? It's an overlap. And since I have 3 subjects, I'm going to try to draw the best 3 circles I can draw. All right. And I'm probably going to label them the 3 subjects I have. All right. So I'm going to hit pause again. I want you to see if you can make the Venn diagram based on the information above, and then push play to check your answers with me. So hopefully when you did that, that's the answer you got. You have to start in the middle